All right, here we have our rates of reaction doodle notes. You should find your sheet that looks like this one. This is our last round of chemistry concepts that we're going to be focusing on. The end is in sight, guys. Get excited. This is the topic that makes up the conclusion of our textbook, the conclusion of all of the chemistry that we're tackling this year. So, we are looking at how these different chemical reactions take place and what rate they do. So there's a few different theories with this. And I'm going to move my face up here so I don't cover up things. Okay, so our first theory is collision theory. And collision theory states that for a reaction to occur, particles must collide with the correct orientation and with sufficient energy. Okay, so an example of this might be, especially when we're studying like radioactive elements and when we're studying like how nuclear energy works, and we remember the video I showed of the particle accelerator for nuclear energy and how we're grabbing the energy produced from a collision from either fission or fusion, colliding or splitting. Okay, so collision theory says particles collide just the right way with sufficient energy and they react with each other. Okay, so here's an example of like a wrong orientation. If they don't hit just right, we're not going to have the right reaction. Or if they don't collide with the right amount of energy, if it's just like a slow-mo, versus here, if they have enough energy, kapow, and then we have a reaction that takes place. All right, our next rate of reaction has to do with concentration. Concentration. So increasing the concentration provides a greater number of particles available to react. This increases the frequency of collisions. Okay, so think about, remember, concentration would have been when we did that sugar saturation, right? We kept adding sugar and sugar and sugar until you couldn't dissolve anymore. And you remember how it would just kind of sit in that water? I've increased the concentration so much that now there is more particles to react with each other. There's more stuff to collide with each other when they're so concentrated. Okay, so here's our example. All right, so there's more particles in the same space, making them more likely to collide and react. Pressure. Okay, so pressure. If we increase pressure of a reaction involving gases, it forces the gases closer together. This increases the frequency of collisions. Okay, so this would be like blowing up a balloon. All right, and you know how you've blown up the balloon so much and you reach that level where you're like, I am a little afraid if I put any more air into this balloon, like we've increased the pressure, right? The same with like a bicycle pump, all right? Feeling that pressure. So when we increase the pressure of the gases, we compress those gases, it maximizes the amount of space there is so that our particles, our gases, can collide with each other. Okay, temperature. Increasing the temperature increases the kinetic energy of particles. Okay, so we have increased the temperature in so many of our experiments this year. You need that heat. You need the energy that comes. Remember when Mr. Book shook my whole big thing of Legos? Oh, here's Zeus coming to say hello. He just can't stand missing you guys. So, increasing the temperature causes those particles to energize with that kinetic energy. Okay, so by increasing the temperature, this increases the frequency of collisions because now they're moving more. And a greater proportion of those collisions have the energy required to react. So the particles, they are all energized, they're moving fast. That means because they're moving faster, they're going to collide, they're going to have energy, they're going to react. Okay, so here we go. We're heating up and our particles have that energy to collide. Okay, catalysts. You've heard me use the term catalyst when I did the cream of tartar in the butterscotch. I said that it was a catalyst. It kind of interrupted something. So a catalyst speeds up reactions by lowering the activation energy required for reaction collisions. Okay, so what this means is enzymes, like our yeast and our sugar were a catalyst together. They were enzymes. Enzymes are protein molecules that act as catalysts in reactions in living organisms. Okay, and so when you think about the word catalyst, it comes from the Greek that means to untie. And so we saw this when you add a catalyst, it's going to speed up your odds of things happening with the yeast and the sugar and the balloon. Using warm water versus cold water impacts how my sugar dissolves, but it also gives that kinetic energy to activate. And then the yeast was able to then totally go as a catalyst, and it was able to then speed up the reaction. All right, surface area. Surface area. Increasing surface area of a solid increases the number of particles that are exposed. This increases the frequency of collisions. Oh, I moved that kind of fast, I'm sorry. Okay, so for you to get those notes. So, a powdered drink mix dissolves faster. All right, so the same thought, like us doing a spoonful of sugar, which is more surface area, versus a sugar cube, right? Okay, the same type of thing of, remember, we looked at surface area way back towards the beginning of the year when I gave you a clean penny and I gave you a dirty penny, and we were seeing how many water drops that we could fit on the surface of the penny, and we were trying to hypothesize what's going to hold more water, like dirt or clean. But the same principle applied. Do you remember how our water kind of created that bubble, on that total curved, like magnifying bubble on top of the penny because of the spread out surface area? The water molecules clung to each other, but they spread out in that surface area. And that is it for reaction rates for taking notes, okay? So you can go back through this video, you can pause, you can fill out your notes, you can color, you can just get your mind around these different ways that the rate of a reaction, so how quickly or how slowly a reaction will take place, these different ways that we can influence it. Our next video lesson is going to look at our textbook, and it's going to be our chapter that really plays more into the vocabulary, more into different examples of how this works. All right, enjoy.